Now you'll notice as we get down to the last half of this series of videos on Chapter 8, this will go a lot faster because these are just reminders of things we've already talked about or know. First of all, we have something called authenticated DHCP. Now you may not know about this one, but the idea of it is that in the process of giving IP addresses out, which is the role that a server or a router serves, which is a role that is either provided by the server, which is the role that is either provided by a DHCP server or by a router. It can be either one. The administrator chooses which way DHCP addresses are distributed. But authenticated DHCP is a twist whereby the DHCP server will not give a device an IP address unless it knows who that device is. In other words, it's had a history of that device. If it doesn't recognize the device, usually its MAC address, then it can send traffic to a captive portal or to an 802.1x server so that the user can identify him or herself before it allows an IP address to be given out. Data protection, in this case, we are simply saying something you already know, and that's that you should use WPA2 or WPA3 today for your Wi-Fi security. And as we've talked about before, WPA2 or WPA3 personal is simply and as we've said before, WPA2 or WPA3 personal, and as we said before, WPA2 or WPA2 or WPA3 personal is like the one you have at home, where you have one password and everybody who wants to get on that network uses that same password. Whereas WPA2 and WPA3 Enterprise uses that radius server, and each person can have a different password. Now, WPA3 does add some additional protections that WPA2 does not have, but it's not yet available on all devices. We should also mention that in both cases, no matter which one of these you're using, both the router and the device itself have to have WPA2 or WPA3 capability. Now most have WPA2 capability today, but WPA3 is not on all devices. So the Wi-Fi card on your computer may not be WPA3 compliant. IPsec stands for IP security, and it's a feature on devices that allow for secure transport of packets at the network layer. The idea of how IPsec works is when the administrator enables IPsec, he or she chooses from an authentication protocol they want to use, an encryption protocol they want to use, and a key exchange protocol they want to use. In other words, you can say, well, I want to use AES encryption, or I want to use some other type of encryption. So those are choices that the administrator makes. And then the administrator also chooses, do I want transport mode or tunnel mode encryption? Transport mode encryption means we're only encrypting the data. Tunnel mode means we're encrypting both the data and the headers. We mentioned a while back that there are several kinds of VPNs, and we have talked about how VPNs work. Here are some others, by the way. So we can make an IPsec VPN, we can make a SSL or TLS VPN, an L2TP VPN, an Open VPN, WireGuard VPN, PPTP VPN, that's kind of a fun one just to say, PPTP, and RRAS, or Remote Routing or a Remote Router Access Server, which is a Microsoft form of VPNs. Mobile device management. We've talked about this just a little bit, but here are three types. One is Client Integrity Protocol. The idea here is that with mobile devices, we want to be able to verify the health of a device before we grant access onto our network. With network-based services, in other words, we put firewalls, intrusion detection systems, and so on. and allow those to help us to control who and when somebody can get on our network. A mobile device management system. Mobile device management refers to, well, we have four kinds here. In other words, on our network, we can verify the health. This is client integrity protocol. We can verify the health of a device. Does it have its latest updates and so on before we allow it onto our network? We can do network-based services. We can have firewalls, NIDs, NIPs, and so on that check everything before we allow a device onto the network. We can use something called mobile device management. In this case, we have a we can also use mobile device management. This is very similar to client integrity protocol, except more specifically for mobile devices. And it can enforce policies. It can make sure that that device is doing a certain kind of encryption or capable of it, that it has remote wiping on it, and restrictions as far as software and so on. Specifically, we can also control access through mobile application management. That is to say, what applications are allowed on a device that connects to our network or not allowed on a device that connects to our network.